Comparison study of the solar radiation effect on the electricity meter in case of operating and non-operating conditions. Abstract_climatic tests are one of the most important type tests that are carried out on electricity meters. Protection against solar radiation test is one of these climatic tests, that is carried out using solar simulators. In this work, the electricity meter has been tested by using a solar simulator developed at High Voltage Laboratory, Egyptian National Institute of Standards, NIS. The test is performed on an outdoor three-phase energy meter at two different cases operating conditions with different loads and non-operating conditions. Also, the accuracy of the electricity meter has been recorded and analyzed before exposure to solar radiation, during, and after the absence of solar radiation. The uncertainty budget of measurements has been evaluated to obtain the actual result of the test. Keywords: electricity meter, solar radiation, uncertainty, solar simulator, type tests. 1. Introduction. Type tests are a set of tests that carry on an electricity meter to ensure that the characteristics of the energy meter are compatible with the requirements of the electricity meter's standard, IEC standards. Solar radiation tests are carried on outdoor electrical energy meters to test their performance when exposed to solar radiation and ensure that the accuracy of the meter does not change during operation or failure in its insulation during exposure to sunlight. The level of protection and insulation of outdoor meters, which are installed outside, is increased because outdoor electricity meters are almost exposed to direct sunlight. This test is carried according to IEC 62052-11, IEC 60068-2-2/2010 1-2. The solar test was performed by using a solar simulator at the level of radiation specified by the standard N equal 1120 W/M2 plus or minus 10%. A solar simulator is an appliance that acts as sunlight through different types of light sources. 3. The output irradiance intensity of the solar simulator depends on many factors such as the number of lamps used, type of light source, the distance between lamp and test area, the distance between lamps. 3. Several research works have been done to build a solar simulator with reliable performance for use in tests and research works. 4-5. Light sources that are used to simulate sunlight are very many with different characteristics such as light-emitting diode lamp, LED, quartz tungsten halogen lamp, mercury xeneon lamp, metal halide lamp, carbon arc lamp, etc. 6. In 2018, Erkata Yandri used 16 units of halogen lamps of 50W for each. The lamps were fixed on an aluminum frame with dimensions of 430 mm x 390 mm x 1000 mm. The distance between the light surface and the test area was 32 cm, giving the maximum non-uniformity of 9.7%. 7. In 2019, Bearer, Anna, ETAL constructed a solar simulator by using 10W of red LED lamp and 3 10W LEDs with color temperatures 3000-3500K, 4000-4500K, and 6000-6500K. 8. In 2020, Al Mansur, Ahmed, ETAL tested solar panels by using a solar simulator with dimensions 107 cm x 92 cm x 72 cm, and contains 4 units of halogen lamps with 0.5 kilowatts for each. 9. In 2021, Haya Kwang, Ekad, and Athapat Matarach designed solar simulator for laboratory research by using 12 units of tungsten halogen tube with a total capacity of power equal 12 kilowatts and the output irradiance of the simulator be 0 to 900 W/M210. Protection against solar test has been done on a 3-phase electricity meter with accuracy class 2 and protective class 2. The accuracy of the electricity meter has been measured during exposure to solar radiation at the operating condition and various electrical loads to know the effect of radiation on electricity meter's accuracy. Also, the energy meter was tested according to IEC standard at non-operating conditions. Then the meter's accuracy was tested before and after the test to analyze the effect of radiation in this case and compare the results between the two tested methods. The uncertainty budget of measurements has been evaluated and taken into consideration to obtain the actual result of the test. 2. Constructed solar simulator. In this paper, the solar test is carried out by using a solar simulator built by adding 4 units of quartz tungsten halogen lamps, QTH, with 250 W, 24 VDC for each on the climatic chamber model, MKF 240. The lamps are supplied through 4 units of 24 V of DC power supply manufactured by Meanwell, through wires coated with a thermal insulator to be protected from heat during the test. The spectrum irradiance of halogen lamps includes wavelengths from 280 nm to 2500 nm as illustrated in Fig. 1, which are close to normal sunlight. 11. The lamps are placed at specific points on an aluminum plate inside the chamber. The solar power meter, pyranometer, model trademark 207, used to measure the output radiation of lamps is connected to an external sensor via a wire with a length equal to 1.5 m. The pyranometer measures irradiance from 0 to 2000 W/m2 with plus or minus 5% accuracy. 12. The climatic chamber that is used can control the environmental conditions from minus 40 degrees Celsius to 180 degrees Celsius and humidity from 45% to 95% RH. 13. The output irradiance of the design simulator equals 1066 plus or minus 15 W/m2 at 26 cm distance from lamps to test area with non-uniformity 8.5% with test area sufficient to test one electricity meter. Figure 2 showed that the radiation distribution inside the chamber during the test. 3. Solar test procedure. According to IEC standard, protection against solar radiation test is performed on electricity meter for 3 consecutive days where the energy meter in non-operating condition and placed inside the climatic chamber and exposure to solar radiation with temperature 55 degrees Celsius for 8 hours, and 16 hours in darkness with temperature 23 degrees Celsius. Then the meter's accuracy has been recorded before and after the test. The energy meter was tested by the standard method. In addition to method differ from standard method to study the solar effect on meter at normal operation. The energy meter has been supplied by its nominal voltage and variable balanced load current using comparator reference standard watt meter and energy meter manufactured by Zera, model, COM303. In the lab, meter's error has been measured and recorded to know the extent of radiation effect on meter under different loads. The electricity meter has been tested at the operating condition and 23 degrees Celsius before exposure to solar radiation as a reference condition. The electricity meter was placed inside the climatic chamber, and its accuracy has been measured at a value of radiation 1066 W/m2 plus or minus 8.5% and ambient temperature 55 degrees Celsius. By considering the temperature generating from the climatic chamber in addition to the output temperature from the halogen lamps, an external temperature sensor was placed inside the chamber over the test area to control the temperature through changing the adjustment of climatic temperature, and noted that the ambient temperature inside the chamber reached to 55 degrees Celsius when the chamber temperature adjusted at 33 degrees Celsius. After that, the electricity meter accuracy was measured after reaching manually room temperature, 23 degrees Celsius plus or minus 2 degrees Celsius. The meter has been tested to know if the effect of radiation will be continuous or electricity meter will back to its normal condition. Many readings have been taken for each value of the applied currents to acquire its average, then the data has been analyzed by Excel program. For the results, the electricity meter's accuracy has been measured by photo scanning head of comparator, COM303-3. Table I illustrated the average of measurement accuracy meter at non-operating condition, standard method. First, at room condition 23 degrees Celsius in the absence of solar radiation. Second, after 3 days which meter exposure to radiation equals 1066 W/m2, ambient temperature 55 degrees Celsius. Fig 3,4,5 show the accuracy of the electricity meter under different loads for each case. After the standard test, the electricity meter has been tested at the operating condition with the same environmental standard value than the accuracy measured before, during, and after exposure to solar radiation. Table 2 shows the accuracy results in 3 cases. Fig 6,7,8 show the accuracy of the energy meter under different loads for each case. Table 2 accuracy test result for the electricity meter at 3 cases. Applied. 5. Conclusion. Solar radiation has a visible transient effect on the accuracy of the electricity meter during radiation, although there is no visible degradation on the outer surface or insulation of meters. This effect of solar radiation doesn't observe when electricity meter has been tested at non-operating condition because the solar effect was transient and disappear when the radiation disappear. The electricity meter returns to its normal operation after the exposure to radiation has been disappeared.